Alright, in this video we're going to look at exponent laws. Now, when I show you these, just understand and know that what I'm showing you may not be the only route to get to the same simplified expression, okay? So you can apply some of these different laws in different ways than I have and still get the same thing, alright? So what I'm going to start with is I'm just going to look at just little pieces of this at a time. For example, 3 squared, well, that's the only number. Everything else is variables and exponents, right? So I'm going to take 3 squared, and let's just simplify that. And we all know that 3 squared is 9. So when I get over here to the end, I know I'm going to have a 9 in my numerator because that's where it was to begin with, okay? The next thing I'm going to look at is the W. And I'm going to notice there are no more W's anywhere else in this expression, so I'm just going to handle just that one spot. So I'm going to rewrite this. So I have W to the -5th. So I need to use one of these rules or laws to help me rewrite that. And if I'll notice, rule number 6 right here tells me if I have a negative exponent in the numerator, I can rewrite that as a positive exponent in the denominator. So I'm going to go to the end and I'm going to do that. I have W to the 5th. All right. So now I'm going to erase this part, and next I'm going to move on to a new variable. So I'm going to look at the x variables. I have x squared here, and I have x to the -2 over there. So I'm going to rewrite that x squared, x minus 2. And again, the only reason I'm looking at it individually is because it helps making the application of the rules and laws a little bit easier. All right. So there's 2 ways we can look at it. We can see this is a division problem. So I can go here to rule number 2, where I have x to the a over x to the b. I just simply take my 2 exponents and subtract them. So my 2 exponents are 2 and -2. So I've got 2 minus -2, which would be a 4. So that's one way you could get x to the 4th by applying this rule or this law right here, rule number 2. Or what I could do is I could use a similar rule that I use for w to the -5th. But if I look over here, rule number 7, I have 1 over x to the -n. So, okay, I have a negative exponent in the denominator. If I rewrite it in the numerator, I have a positive. So that would change to x squared times x squared. And then I would utilize rule number 1 right here, which is x to the a times x to the b. I simply just add them. Either way, I still get x to the 4th. So you can see I applied a couple of different laws in different ways, but either way I still got the same answer, and that x to the 4th remains in the numerator. Okay? Next, I'm going to go look at all of my y values. If you'll notice, there's only one y value right here in the bottom. There are no other y's anywhere else. But if you remember, if there is no exponent, that's like the invisible 1 exponent right there. And so since there are no rules or laws to apply to it, I'm just going to leave the y down there in the bottom. Next, I'm going to move on to z. So I have z to the -3rd, z to the -3rd. So I'm going to rewrite just that here. Z to the -3, z to the -3. I'm going to apply the division rule right here, rule number 2. So x to the a over x to the b. I simply take my 2 denominators and I subtract them. So I have z to the -3 minus -3, which becomes plus a positive, which becomes z to the 0 power. Now, if we'll notice here, rule number 8 says anything to the 0 power is just a 1. So now I know it's z to the 1. And I could write that in there like this, but I know 1 times anything is just itself. So my simplified answer of that expression is 9x to the 4th over w to the 5th times y. All right, now I want you to pause it, try this one out on your own. Again, utilize those rules up top and see how far you can get. All right, now that you've had a chance to try this on your own, I'm going to work it with you. All right, so I have equals, and I'm going to do this so that I can put my final answer here, but I'm going to leave some space for myself to work right here. First, I'm going to look at just these first 2 terms, right? I'm going to look at 10 and 5. So 10 over 5 equals 2 over 1, which just leaves me with a 2 in the numerator, right? All right, so just like a regular fraction, I just reduce that. Next, I have p to the 12th over p to the 3rd. And if you'll notice here, I have p to the 12th over p to the 3rd. I'm going to use that the division rule, that second law. I have p to the 12 minus 3, which simply becomes p to the 8th. All right, and I'm going to erase this one in the middle. And here, same rule, into the 7th over into the fifth, and I'm going to subtract those two and get n squared and just get n squared. Now, if you'll notice, I don't have anything left in my denominator. That doesn't mean it's a 0 down there. It just means everything has turned into a 1. I can rewrite that as 2 times p to the 8th into the second. And that is my simplified solution. Now, in no way, shape, or form could I begin to even show you every possibility when it comes to using all of these exponent laws or rules. So this is just a situation where you're going to have to practice a whole lot in order to get good at these. Hope this video helps, and I'll see you.